So hope you can hear me well as well. So hello and welcome all to the presentation of offloading data plane from the network services for telco use cases. So who are we? Myself, Roshni Ratnam. I work as a lead architect at Ericsson. So today you will hear from some more colleagues. Tariq Hammam, he's working as a system manager at Ericsson, and as Francian, technology specialist at Ericsson, and Yuan Lunglet, developer from Ericsson. So what is our approach to NSM? So we are driving different studies that have been broadly looking at different possibilities given by NSM, and also looking at different areas that where things could be developed to further serve some of the telco use cases, also different network connectivity scenarios with Kubernetes using NSM. And we are also doing different experiments to look a bit beyond what NSM provides today out of the box. Also, we are looking at how architecture could conceptually be extended to accommodate some functionality prerequisites and decide properties for using telco networks. One among such architecture improvement that we have looked at is offloading data plane from NSM network service. So with that introduction, we will walk you through background, why we have looked into this whole architecture update and the use case. And we'll also walk you through experimental setup and a demo, and also a broadening of use cases with the concept that we are presenting, and also key takeaway from the presentation. So with that, Tariq Hammam will start describing the background. Tariq.
Is Tariq having difficulty with his audio? Let me check and see if there's something I can do to make that better. He should be fine for both audio and video, but he probably has to unmute them both.
Can you hear me now?
Yes.
Oh, yes, good. Excellent. Thank you.
Good. So, shall I start video here also? Let's see if that works. So, can anyone see me now or no?
I'm just seeing a black screen.
Oh, well. Okay, it worked with Skype, but oh, yeah, that's interesting. Yeah, so I think we'll have to make do then without it if I can't. Yeah, fault locating may take some time here. Should have tested this with Zoom. Okay, so I'll start here with giving some background, basically to our thinking and also the demos that we're going to show. And one can't assume that everybody here in the audience is familiar with typical telco clusters, so I'll try to just take the essentials here and give the big picture to start with. In telco networks, in the core network, which is a higher part of the network, it's very common that the nodes, for instance, call handling nodes, network databases, policy databases of various sorts, they use some clustering technique, okay, for basically getting the processing capacity that they need. And then they are typically connected to some gateway setup, and that gateway setup is, it constitutes basically the demarcation toward the external networks, and also takes care of the interworking with external network and ultimately with remote parties on the other side of the external network. And the remote parties, that can be other telco nodes, which is the most common case, but it can also be user instruments like mobile telephones or other forms of user instruments. So this is a very abstract picture, and maybe it's worth to note that the gateway setup and the cluster setup, it's very common that that's part of the same telco equipment. But yeah, in some cases it can also be, the gateway parts can be part of various customer premises setups. I think we can take next picture. So going from this very abstract level here and look a bit more concrete and with Kubernetes and cloud native and so on, and NSM in particular, what is it that we want to achieve? Okay. So if we have our core handling services running here on application level in the Kubernetes cluster, okay, we need, of course, to connect somehow to this gateway setup. And that we do over some front-end devices in the cluster, okay, which have physical connectivity, of course, to the gateway setup. The most typical configuration is basically to use VLANs here, okay, so it's and normal routers, L3 routers, IP routers, and VLANs. And then we connect to an external network through these gateway routers. And on the other side, we have telco nodes or user instruments. So the connectivity between the cluster and the gateway setup, that is, of course, is highly interesting for us, how that is done and how that's done effectively. Okay. And the other thing, of course, that comes to mind is capacity. One want to be able to handle the packets that come in, the traffic generated from the network in an effective way. Some form of fast pass solutions is sought. So I think we are ready for the next picture. So a little here about NSM and why we found NSM particularly interesting, and that is that NSM is logically based on a cluster-centric concept with distributed NSM clients. And that alone is of course not enough, but NSM also has a concept of service endpoint, whereby an application pod, by means of NSM, on the client side, is provided access to a secondary interface associated with a corresponding NSM endpoint. So we get basically a framework here where we can start to do interesting things, okay, and model interesting things, okay. So then we start looking basically at the two issues I mentioned before. Okay, how do we do with basically the front end interconnection with NSM, and how do we basically get capacity into all this? So it is here suggested that offloading the data plane from the network services could facilitate a desired practice of front-end interconnection to the external networks via a gateway setup. For instance, using VLANs, okay, in the most simple case. Furthermore, the said offloading would allow for an use of acceleration techniques in the data plane for a faster packet processing in the communication with the remote parties in the external network. And what we're thinking here is basically things like smart NICs and things like that to create a fast pass for the packet handling. And what we say here, that therefore it is desirable if the NSM architecture in its development trajectory would conceptually accommodate means for a client-invoked setting up of an application scope separated control and data plane, which would permit a delegation of packet handling to separate data plane devices. Okay, and these devices, I mean, that could be switches or things done you can think of it as switches, devices that are not in the pod but controlled from a Kubernetes pod. And we're trying to show this in some figures here and also our experiments. So we can take next picture. So if we start with the figure here, okay, we show a figure where we have a Kubernetes cluster, and then we have two pods. The green one, which is an application pod, which would correspond here to an NSM client, okay? And the application running in this pod would like to speak to the remote parties in the external network. But to do this, we need some help here from an NSM endpoint, okay? And we call it here the front-end endpoint. And the front-end endpoint basically runs software which controls, okay, the data plane or devices in the data plane that takes care of forwarding and also interconnect to the VLANs, okay, cross connect or interconnect to the VLANs. And then we have a control plane, of course, so that the pods can communicate and run the protocols necessary for NSM and so on. But the idea is basically to control the devices in the data plane primarily, okay. But then to achieve a fast pass. But then, of course, in some cases, it may be necessary also to have an optional way of getting packets, also some packets at least up to the front end pod, okay. A slow pass, you could see. That is not always needed, but sometimes needed. But the idea is to switch through the packets to the application. That is basically what we want to achieve here. And so separating the control plane and data plane, that we think is key for a fast pass processing. Plus, it can facilitate the front-end connectivity, as we're going to show in our demo. I think we are ready for the next part of the presentation, which is the experimental setup and the demos. And I'll hand over to my colleagues here who can explain that, how we've done that in more detail. And then we will come back to the general model later on. Okay.
Yeah, can you hear me?
Yes.
Yes, Johan, loud and clear.
Okay, great. Try to turn on the video. Is it okay? I can see myself at least.
Go ahead, Johan.
Yeah. Roshini, I think you can share the slides, actually. Can you take it back?
Yes, please go ahead.
Okay, so this illustrates the test environment where we've done our proof of concept. And it's a quite standardized cluster. I mean, there are 4 worker nodes, and then there's an external router and switch. The only thing that might be of notice is that there's an extra interface on each of the nodes. Yeah, I think we can continue. So we start the procedure by deploying a VLAN NSE, the endpoint. So far, it's a quite standard NSM procedure, and it's deployed on one of the nodes. Yeah, let's continue. So here we have 4 clients that each request a VLAN from the NSE. So even here, it's quite like normal, like standardized NSEs and NSEs. And we can continue. And yeah, so here at this point, VLANs are injected into each of the NSEs, and they are created NSM0 interfaces. The difference here is that there is no NSE 0 interface created at all on the NSE side. They are only created here on the NSEs. Yeah, let's continue. So after that is done, it's possible to reach NSEs from the external router after manual configuration. Let's note that the configuration of the router is not part of the automatic setup done by NSM at this point. So by then, each of the NSEs should be directly accessible outside of the Kubernetes cluster. So to demonstrate this, we have a demo. And now I can take over the screen sharing. Is it looking okay?
Yes.
Okay. So here we have the 4 worker nodes as described in the previous slides. And yeah, these are the external routers, and we just use one in this case. So if we look at what has been deployed here, we can see that there is one NSE here and the 4 NSEs. And if we log into the or access the NSE, you can see that there is no NSM0 interface here. So it's nothing on this side. And if we instead check in one of the clients, here we have that NSM0 interface we mentioned. And if we then, yeah, now I prepared this, but if we do this manual setup on the router here, and then we should be able to access by just for demonstration purposes. So that is possible to reach it. And yeah, the other ones as well. So basically this demo is, yeah, we just want to illustrate what we wanted to achieve with the separation aspects. And by that, I think we can go back to the main presentation. Yeah.
Thank you, Yuan. So this is the example demo that Yuan presented now, where you see the network service will only include the controller part, and it's not involved in the traffic flow. And by that, we will move to the broadening of use cases and key takeaways. Tariq and Anders will summarize the use cases with this improvement and takeaways of this presentation. Tariq.
Yes, so I'll try to see if we can get the video working now. Okay. Cameras will occupy other apps. Okay. Please try again. Ah, this is hopeless. Okay, we'll have to make do without it. So Roshni, maybe you could just bring back the previous picture you had where before we start looking at the broader cases. So if we look here at the demo, that all fitted into this model that we had here. But in the demo, there was basically the arrow, the bright arrow was from the FE controller, the data plane. That was not existing in the demo, it was not needed. Okay, so that was one case where this was not needed. A case where you would have a need for that is basically if you would run a routing protocol in the front end endpoint, okay, OSPF or ISIS, BGP or something like that, to announce IP addresses and attract traffic from the external network. Then you would need a slow pass, basically, to bring up packets like link state information and other things to the routing protocol that would be running in the pod in the network in the front end NSM endpoint. So that is one case. So this is a small broadening of the concept, but the same model, the optionality you need to have here to have flexibility. So I think flexibility is a key word. Okay, Roshan, I think we can take the rest now. So, yeah, here in this picture, what we've added is basically now we've added some service chaining here. Okay, we have added an intermediary, another function here, an intermediary function, which could be a load balancer or a router of some sort. Okay, and an application pod would then act as an NSM client, and the intermediary function would be both an NSM endpoint and an NSM client at the same time. And then there are many different cases here because there are cases where one would like to get packets up to that intermediary function and inspect them and do things with them and pass them on to a forwarder on the other side. Okay, but there are also cases where you would like to have a fast pass and switch through. Okay, packets coming from the external network or the VLANs. And for that, you would need to have some form of conduit between the forwarder and cross connect this. The important thing is that there are lots of different configurations and possibilities, but the thing that is good to have is an architecture that allows for this flexibility and have the concept that one can build this. And we know that allowing for having different data planes in NSM, that's work that's ongoing. So I think things like this could be part of that development in the future. Yes, Anders?
I just want to add, if I would tie back to the presentation Dominic had about, what NSM is. I mean, it is a process with an outbox and an inbox. What we have done here is to remove the endpoint 2 and made that one external, because we cannot build the complete world in NSM. We need to adapt to what's already out there. I mean, we have a lot of customers things that is already deployed. So then what we would like to do is to have like the endpoint 2 being like external, and we don't care for that in the application. We only care for the inbox and the outbox of our application. I mean, we send something, we get something back, exactly as you said from the beginning.
Very well said. Okay, so it's basically delegating. It's all about the delegating to other devices. Okay, and keep the control in a pod in a endpoint, NSM endpoint. That's a key reoccurring thing here.
So there's a little bit of Q&A. If do you guys want to take a look?
We have one more picture maybe to
Perfect.
Take briefly here and before Q&A, and then we'll move to the Q&A straight. To take it a bit further, what is quite common here is that you have you also want to keep separation, VPN separation in the cluster, okay, and interworking with externally with the different remote parties, because they may reside in the completely different separated VPNs. And likewise, you would have applications, pods running that should just speak and communicate with remote parties in one particular VPN. So we've colored them here, blue, red, and green, and that would correspond to the VPNs, which are also colored blue, green, and red. And so that's one aspect. The other aspect, when we talk about the intermediary devices, you would like to have some of these intermediary devices inside the cluster also, like load balancers, and if you have a load balancer, then basically the traffic from the external VPN, they would come into the front ends, and then they would be load balanced over a number of pods of the same color. Okay. Things like that. But exactly. There are lots of combinations and lots of. So the good thing is to have, at least with respect to NSM, a model that allows for this kind of flexibility. And we think that key to this is basically the offloading of the data plane. If one can do that, then it leaves the possibility to build flexible architecture. And as Anders here pointed out, basically the delegation to delegate the low-level packet handling to other devices. Okay. Then things would be very complete and very powerful.
Did I say that, Tarek? What I actually wanted to say that we don't want to implement the network, the complete network service within NSM. We want to have the ability to have functions outside of NSM.
Yeah. So the external devices would be outside of NSM, but they could be controlled from NSM. That's what we intend. At least my intention. Great. Thanks.
So we got one question and that's answered, but still maybe it will be interesting for others to know. The VLAN tagging is done by the data plane, VPP, that was the question. So for the demo, it's done in the kernel forwarder. Though for the demo purpose, we have to hard code, but yeah. So that's in the kernel forwarder that we have used in the demo.
Yeah, maybe we could add that the demo is a bit of a hackish. We are looking forward for this new NSM architecture with multiple forwarders, because then we could have a specific breakout forwarder made already, I guess.
Yep. We have a bit of a talk on some of that here a little later in the day as well.
Good.
Okay, so are there any more questions? Otherwise, we are done with the demo.
Cool. I would encourage folks to, if you have further questions or want to have further discussion, to engage on the #NSM Slack channel at CNCF Slack. There have been some really good discussions happening there. We had a couple other questions that popped up on the Q&A. Do you want to go ahead and read those out and answer them live, or would you like me to read them out? I'm fine either way.
Okay. How to handle overlap between Kubernetes networking CIDRs, primitives, and NSM external routing?
Do you guys mind if I just drop a quick mention of exclude prefixes there?
Go ahead.
So Adele had asked about how do we handle overlap between Kubernetes networking kitters, primitives, and the NSM external routing. One of the things in the mechanics of network service meshes is negotiating its L2, L3 connection is from the client side. An exclude prefixes ends up being added by a component in the system that contains the kitters for Kubernetes networking. And so the network service endpoint, whatever it is put on notice that it's not okay to overlap with this. If they try and return an IP address to be assigned to the interface that overlaps with this, we won't actually do that for them. If they try and ask us to route IPs to them that overlap with those excluded kitters, we won't program those routes for them. And so effectively, we won't allow the stomping of the Kubernetes networking. We take a very, very strong first do no harm principle, and we put a lot of thought into making sure that whatever it is the network service mesh is doing, the standard Kubernetes networking works. Did it answer your question, Adele? Cool. Feel free to drop on the #NSM. We can talk more about that. Cool. Do you want to walk through some of the other questions that you guys have?
Yeah, one more is there. So is it like the forwarder creates a VLAN tagged interface, then forwarder injects that interface as NSM0? Yes, on the same node as the client is sitting.
Yeah, if this is the first request on the first service request. If it's the second service request, it will be NSM1, of course. And it is done on the forwarder that is closer on the same node as the client is sitting, at least with this implementation.
Does that answer the question?
I mean, it can be NSM1 or 2.
Yeah.
Cool. All right. I think we've sort of gotten to the end of the existing questions. I would encourage folks to